Welcome to Spaceverse, your portal to cosmic adventures. In 2023, NASA's James Webb Space Telescope captured a stunning image of the Sagittarius C stellar nursery, located in the very heart of our Milky Way galaxy. This breathtaking snapshot has since become a valuable tool for scientists, allowing them to delve deeper into one of the most mysterious and complex regions of our galaxy. With its advanced instruments, Webb's infrared capabilities have given us a closer look at the dynamic processes of star formation and the effects of powerful magnetic fields on interstellar gas, offering a glimpse into a previously uncharted territory of space research. But what's so special about this region? Researchers have long been curious about the central molecular zone, the dense and mysterious core of our galaxy. The question at the forefront of many minds is, why are so few stars born here compared to other regions in the galaxy? To help answer this question, scientists have turned to Webb's groundbreaking images. Among the leading researchers investigating this phenomenon is John Bally, an astrophysicist from the University of Colorado Boulder. Bally, one of the principal investigators on this project, explained, "A big question in the central molecular zone of our galaxy has been, why are so few stars born here? With its high concentration of dense gas and cosmic dust, this region presents a challenge for star formation, making it an intriguing puzzle for astronomers. At least on a microscopic scale, we are now seeing firsthand how powerful magnetic fields may inhibit star formation," he continued, highlighting the significance of Webb's images in uncovering this hidden cosmic process. Thanks to Webb's unparalleled near-infrared technology, scientists are now able to peer through the thick clouds of gas and dust that once obscured our view. For the first time, we can observe the intricate birth of young stars in unprecedented detail, shedding light on processes that were once entirely hidden from our view. These revelations mark a groundbreaking achievement in our understanding of star formation. Among the researchers using this data is Samuel Crowe, a senior undergraduate at the University of Virginia and a 2025 Rhodes Scholar. Crowe has described the extreme environment at the Galactic Center as a fascinating natural laboratory for testing star formation theories. With Webb's infrared capabilities, he notes, we now have the ability to build upon earlier discoveries made by ground-based telescopes like ALMA and MEERKAT. These new insights are set to reshape our understanding of the life cycle of stars and the complex forces at play in the galactic center. This cutting-edge research is not only advancing our knowledge of star formation, but also contributing to the scientific community's understanding of the cosmos. Recent papers co-authored by both John Bally and Samuel Crowe were published in the Astrophysical Journal, further expanding on their findings. As the James Webb Space Telescope continues to unlock the mysteries of our universe, the Sagittarius C stellar nursery remains a focal point of astronomical research. Through its unmatched capabilities, Webb is helping us explore the deepest, most enigmatic corners of space, revealing new discoveries that will shape the future of astronomy for generations to come. Let's take a look at the stunning view captured by the MEERKAT Radio Telescope Array, formerly known as the Kourou Array Telescope. This remarkable image shows us the center of the Milky Way, a chaotic, dynamic place where supernovae have erupted over millennia, leaving behind remnants that paint a picture of the violent history of our galactic core. What we see here is not just a snapshot. It's like a super long exposure, showcasing the dynamic nature of this tumultuous region. These bubble-like relics of supernova explosions tell a story of stellar life cycles, showing us the remnants of once massive stars that have detonated in spectacular fashion, their explosive energy rippling through the space around them. At the heart of this image lies the brightest spot, the supermassive black hole at the center of our galaxy, Sagittarius A. This intense gravity well pulls everything towards it, from nearby stars to the gas and dust surrounding it. And just a little further out from this central black hole, we find a fascinating area of star formation, Sagittarius C. Now we move on to the incredible work of the James Webb Space Telescope, which has peered into the heart of the Milky Way to reveal stunning details of this star-forming region. Situated approximately 200 light-years away from Sagittarius A, Sagittarius C is a stellar nursery, where new stars are being born at an incredible rate. Webb's infrared view has allowed scientists to see through the cosmic dust, uncovering structures and processes that were previously hidden. In Webb's image, we see a dramatic, vertical filamentary structure in the blue-green hydrogen cloud of Sagittarius C. These filaments are evidence of the complex processes at work in this star-forming region. Webb's advanced infrared sensors were able to capture the smallest details, showing how these structures are shaping the formation of stars and potentially influencing the way the galaxy evolves. Interestingly, Webb's infrared observations also reveal the different types of emissions coming from this region. The spectral index shown in the bottom left corner of the image helps us understand how the colors in the image were applied to the radio data, providing insight into the processes that are at play. Non-thermal emissions caused by electrons swirling around magnetic field lines can be seen in the image, as well as thermal emissions which come from heated, ionized plasma. By converting infrared data into visible light hues, Webb gives us a color-coded map of the region, with longer infrared wavelengths appearing more red and shorter ones taking on a bluer hue. The findings of Webb go even further, helping us to observe the birth of massive stars. In the brightest cluster of Sagittarius C, 2 enormous protostars are currently in development. These stars are already over 20 times the mass of our Sun, and their growth is accompanied by brilliant outflows of energy. Webb's detailed imaging has allowed scientists to study these massive objects in a way that was never before possible, giving us a glimpse into the future of star formation in our galaxy. But it's not just the massive stars that Webb is helping us discover. The telescope has also helped to identify potential low-mass protostars, which are much harder to detect due to their encasement in thick layers of cosmic dust. By combining Webb's data with previous findings from the Atacama Large Millimeter Array ALMA, scientists have identified 5 possible low-mass protostar candidates in this region. These tiny stars, still in the early stages of their formation, will eventually grow and evolve into fully fledged stars, contributing to the ongoing cycle of stellar birth and death. Together, these findings from both Meerkat and Webb offer us an unprecedented look at the inner workings of the Milky Way. From the explosive remnants of supernovae to the delicate filaments of gas and dust shaping new stars, we are seeing our galaxy in a whole new light. The collaboration between these 2 cutting-edge telescopes marks a new era in our understanding of the cosmos, and as technology continues to advance, there's no telling what incredible discoveries await us in the future. Deep within the heart of our Milky Way galaxy, astronomers have uncovered yet another fascinating piece of the cosmic puzzle, this time in the form of 88 peculiar objects. These aren't stars or planets, but rather telltale signs of intense and energetic processes. Shocked hydrogen gas, created when high-velocity material ejected by young, forming stars slams into the surrounding gas clouds. These shocks ripple outward like the wake of a speedboat, illuminating the interstellar medium and revealing the otherwise invisible drama of stellar birth. What's more, this analysis led to an even more surprising discovery, a completely new star-forming cloud separate from the well-known Sagittarius C region. Nestled in this newly identified pocket of space are at least 2 protostars, infant stars still in their early stages of development. Each of these protostars is already launching powerful jets, actively reshaping their environment as they grow. It's a sign of the vigorous, almost chaotic nature of early star formation. While astronomers had previously identified outflows from young stars in Sagittarius C, this is the first time such activity has been confirmed through infrared observations. That confirmation, made possible by the James Webb Space Telescope, is groundbreaking. It marks a milestone in our ability to peer through the thick curtains of cosmic dust that obscure the galactic center in visible light. According to lead researcher Crow, the discovery is extremely exciting, especially because the process of star formation in the central molecular zone, one of the most important and least understood regions in our galaxy, remains largely a mystery. But the story doesn't end there. In a heated, turbulent zone of ionized hydrogen plasma surrounding the core of Sagittarius C, the James Webb Space Telescope's 2023 image revealed a mesmerizing network of delicate, glowing filaments, dozens of them, each a thread in the fabric of star formation. These filaments are more than just cosmic eye candy. They hold clues to the invisible forces shaping this region. Astrophysicist John Bally and his team believe magnetic fields are the architects of these structures. These fields, previously detected by ground-based observatories like ALMA and the Meerkat Radio Array, aren't static or gentle. They are twisted, stretched, and intensified by the immense gravitational forces near the supermassive black hole at the center of the Milky Way, Sagittarius A. As gas swirls around this gravity well, it drags and winds the magnetic fields with it, creating a powerful framework that influences everything nearby. This magnetic scaffolding, the researchers believe, is responsible for concentrating the plasma into the slender filaments we see in Webb's images. Instead of allowing the hot, ionized gas to disperse, these fields contain it, guiding it into narrow, structured channels. It's as if unseen hands are threading plasma through the galaxy's inner core. Perhaps most intriguingly, these powerful magnetic fields may also explain why star formation in Sagittarius C appears to be slower than expected. Normally, dense clouds of gas and dust would collapse under their own gravity, forming new stars in rapid succession. But when strong magnetic forces are in play, they can act as a counterweight, resisting collapse and throttling the birth rate of new stars. This tug-of-war between gravity and magnetism adds another layer of complexity to our understanding of stellar nurseries. As Crow notes, the influence of magnetic fields, especially in the galactic core, on stellar ecology is still largely unexplored territory. It's a promising frontier, one that could help us understand not only why stars form where they do, but how entire galaxies evolve over time. From shocked gas and jetting protostars to magnetic threads and plasma filaments, these discoveries paint a vivid portrait of a galactic heart that is anything but quiet. The Milky Way's center is a place of raw power, hidden beauty, and cosmic mystery, and thanks to the James Webb Space Telescope and the continued work of scientists around the world, we're finally beginning to lift the veil. If you're as fascinated by the mysteries of the universe as we are, be sure to like, subscribe, and join us on the next journey through space and time.